The mason jar and the sand, that represents our body fluids in our body. And the magnets, they represent antibodies. And they are also known as immunoglobulins. And they are defensive gamma globulins found in the blood plasma, tissue fluids, body secretions, and some leukocyte membranes. And these are our antigens that are in our body. And an antigen is a molecule that triggers an immune response. The region of an antigen molecule is called the epitope, and that is what stimulates the immune response. And then some molecules can be called haptens because they're too small to be antigenic in themselves. These are antigens that are being introduced to our body and they're foreign, such as like viruses, bacteria, any other thing that's not just normal in our body. And then here are our antibodies that are being produced and released into our blood or body fluids, and they are going to attract to the antigens and render them harmless by 4 ways. The first way is neutralization, and this is where only certain regions of the antigen are pathogenic, and they can neutralize any antigen by masking these active regions. And then the next example that they neutralize it by is complement fixation, and this is when they bind to the actual enemy cells and change shape, exposing their complement binding sites, which initiates the binding of complement, which leads to inflammation, phagocytosis, immune clearance, and cytolysis. The third way is agglutination, which you'll be able to see clearly. If I can get it out. This is where the antibodies bind to the antigen 2 or more enemy cells at once, and they stick together, and it prevents them from spreading through the other tissues and renders them harmless. And then the last way is precipitation, and antibodies link to antigen molecules, and this creates a large antigen-antibody complex that is too large to remain dissolved in the solution, and this is removed by immune clearance or phagocytized by eosinophils.